Okay, hello everybody, and welcome to my talk, All Your Fitness Data Belongs to You, Reverse Engineering the Huawei Health Android app. My name is Christian Kruderer, and I'm a security analyst and researcher at SB Research. Furthermore, I'm a PhD candidate at TU Wien, and I'm mainly interested in IoT, embedded, and hardware security. Okay, can we please turn on the microphone? Thanks. Okay, before we start, I want to give you a short overview about my talk. We will start with my motivation, why I started to reverse engineer the Huawei Health Android app. Afterwards, I will give you a brief introduction into Bluetooth Low Energy. Then we will talk about static and dynamic program analysis. And in the ending, we will talk about the Huawei Link protocol, and I will give you a short conclusion. So let's start with my motivation. In December, I decided that I want to buy a fitness wearable. And the reasons for that was that I was very interested in my pulse monitoring, in the tracking of my activities, and I hope that it motivates me to do more sports. This worked not out this quite well, because the first 3 weeks after receiving the watch, I used every 3 minutes to reverse it. So here you can see the watch, and also in this picture. And my reasons for the Huawei watch were that I wanted a watch with a good battery life, and this watch has an incredible battery life, about 10 to 14 days. It has a affordable price, and it has a reliable hardware, according to some reviews you can find in the internet. So here you can see a screenshot of a pulse recording of 1 day. And this screenshot is from the Huawei Health app. And the problem with this app is that it's not possible to export your fitness data and your heart ratings or your heart monitoring. At least this was the problem before I started the reverse engineering. Because all the data are stored in an encrypted SQLite database. But now I'm able to do this. I can extract the data out of the encrypted database, and I can use the data for any purpose I want. For example, here I created a simple Python matplotlib plot for the same day. So what was my motivation for reverse engineering the Huawei Health app? First of all, I do not want it to be dependent on the Huawei ecosystem. I don't want to upload my personal data to the internet in any cloud. The Huawei ecosystem has no possibility to export the data, at least no export possibility to local file storage. You can share your data with Google Fit, but this was not an option for me. And I think another big problem with all these ecosystems is the end of product lifecycle. For example, for the Suunto MovesCount application, there is this MovesCount web application, and the lifecycle will end in 2020. And when you have an old Suunto device, you cannot use it anymore then. And of course, reverse engineering is a lot of fun. So what are my objectives of this talk? My objective of this talk is to give you an introduction into Android reverse engineering and to share my results with you about the communication protocol and how you can extract the app out of the data. And during the reverse engineering, my objectives were to understand the communication protocol between the smartphone and the watch, and to extract the personal data out of this encrypted database. So let's talk about Bluetooth Low Energy. In this image, you can see how the generic attributes work. In general, Bluetooth Low Energy has a stack with different layers, but for this talk, only the generic attributes are interesting. And at the generic attribute layer, there's a client and a server. And the client can get some information from the server. And in our case, the client is the smartphone, and the server is the Huawei watch. And the generic attributes define a hierarchical data structure that is exposed to connected Bluetooth low energy devices. And the top level of the hierarchy is a profile, which contains one or more services. So we can see the services here in orange. And each of these services contains characteristics. And you can read these characteristics, you can read the values from these characteristics, or you can write a new value into this characteristic. So Huawei is using this characteristic concept a little bit different. They only use two characteristics, one to write to the watch and send their own commands, and they use a second characteristic to extract the data. So when I started with the reverse engineering, I had no idea about the communication protocol. The only thing I know was that it's using Bluetooth. But at Android, you can sniff the Bluetooth communication. And this is an option in the developer options. You can see it here on the picture. You can enable it, and then the smartphone will create a log file, stores it to the SD card. You can download it from the SD card and open it with Wireshark. So here you can see a screenshot of my Wireshark analysis. And in this picture, you can see the first write command from the smartphone to the watch. And of course, I had no idea what this write command was, and I was very interested to find some information about it. So I decided to do some static program analysis. And the first step is that you need the app before you want to analyze it. And I started with the extraction. And there are different methods how you can extract the app out of your smartphone, or how you can receive an Android app. And I think the easiest one is a web page called APK Mirror. It's an archive of downloadable Android apps, and you can download the current versions, but also older versions. That's really nice because this is not possible with Play Store. Of course, only free apps are available since APK Mirror has a no piracy policy. But unfortunately, not all free Android apps are available. So sometimes you need to use some different method. And another method is the Android Debug Bridge. This is a command line tool that lets you communicate with your device, and it's part of the Android SDK platform tools. And it can be used to extract the app from non-rooted or rooted devices. So you can hear, in this slide, you can see an example how I did this for the Android Health app. In the first step, you have to find the APK name of the Huawei Health app. Then in the second step, you have to find the path. And afterwards, you can use the adb pull command to download the app to your local system. So the third method I want to show you is an app called APK Extractor. And you can install this app from Play Store, and this app extracts the app and stores it on the SD card, and it does not require root access. But in my opinion, it has two disadvantages. You have some advertisement in the app, and you have to trust the developer of the app that it does not modify the app during the extraction. So after I was able to extract the Huawei Health app, I wanted to decode it to get some information out of it. So, and in general, APKs are zip files containing resources and assembled Java code. And if you simply unzip an APK, you would be left with binary files. For example, the Android manifest XML is in format Android binary XML. So they are not human readable, and it does not really make sense to unzip an APK. But there's a tool called APK tool, which can decode apps. And you can see the example here in the black window for the health app. And for me, the Android manifest was very interesting. So let's talk about the Android manifest. Every app must have an Android manifest in its root directory. And this manifest provides essential information about the app to the Android system. And the Android manifest is very interesting from a security point of view because it answers the question if debugging of the app is allowed and if you are allowed to create a backup of the app's data. And unfortunately, both flags were disabled for the Huawei Health app. So you are not allowed to create backups and you are not allowed to debug the app. So I thought, okay, with MPK tool, I also can repatch the app. I can change the Android manifest, I turn on the debugging, I turn on the backup function, but it's not that easy. Because there's a known issue for apps which uses Android keyword. Android keyword is an obfuscation tool, and when you use this obfuscation tool, you cannot rebuild the resources with APK tool. But repatching the Android manifest requires the decoding of the resources. So for the Huawei Health app, you can only modify the source code, but not the resources and not the Android manifest. But I think it's very good to know how it works. So therefore, I prepared one slide to show you. So you can rebuild the app with APK tool, and then before you can install it, you have to re-sign it. And on GitHub, there is a ready-to-go tool or framework which can do that. And you can re-sign it with Android test certificate. And after the rebuilding and the signing, you can install the app with ADB tool. And even if the repatching would be possible for the Huawei Health app, it's not that simple because the Huawei Health app checks its signature during startup. And if the signature doesn't match with the stored signature, it exists with an error. So there are two possible solutions. One solution is to find the signature check and modify it, but this is very time consuming. And the other possibility is to modify the app during runtime. This is easy, and we will come to that. So in the beginning of my talk, I also told you that there are encrypted SQLite databases. And I was very interested about these databases, and I wanted to extract them. So there are 3 different methods how you can extract the app's data, and I want to show you to them. The first one is the run as method, but it requires the debugging permission. So you have to check before if debugging is allowed in the Android manifest. And if you're allowed to execute the run as command, you can simply copy the data to a SD card, and afterwards you can download it to your file system. Another method is the creation of a backup, also with ADB, but it needs the permission that the backup creation is allowed. And when you create a backup or when you start this backup creation, you will be asked on your smartphone if a backup really should be created. You can see it in the screenshot here. And after you have created this backup, you can extract it with a tool called Android Backup Extractor. And the third method is the, in my opinion, preferred method, but it requires a rooted device. And there you can simply copy as root the data to the SD card, and afterwards you can download it. Okay, so let's talk about decompilation, deobfuscation, and code analysis. So how does code execution on Android works? An Android application package, an APK, contains one or more Dolric executables. So you have a classes.txt, a classes2.txt, and so on. And the Darvik executable specification limits the total number of methods that can be referenced to about 65,000 methods. And the Huawei Health app has over 170,000 methods, so multiple text files are necessary. So you see the Huawei Health app is a huge app. It has a lot of lines of codes, so reverse engineering, you can spend a lot of time doing that. And the Darvik executable contains bytecode, which is executed by the Android runtime. Okay, so how can we decompile a Java application, an Android application? There is a tool I prefer, it's called JDX, and it's a command line and graphical user interface tool. And you can use it to decompile text files and APKs. So with the tool, you can also use it for static source code analysis in the graphical user interface, but I prefer to use Android Studio. It has also a deobfuscation functionality, but I prefer to do it manually because of false positives. And sometimes JDX is not able to decompile some methods, then you have to try other decompilers. And on the end of the slide, you can see an example how you can decompile an app with JDX. So after the decompilation, you can import it into Android Studio. So let's take a small recap. After my Wireshark analysis, I know that it's using Bluetooth, low energy. I know that I'm not allowed to debug the app. And I have extracted the app and have decompiled it. So I searched in the internet how does Bluetooth in combination with Android works, and I found the documentation for the generic attributes in the Android SDK. You can see it here on the screenshot, and it says if you want to connect to a remote device, you have to use the connect-geth method. And Android Studio has a really great functionality. You can search in all files. And when you do so, so you open this functionality with the keys Control, Shift, and F, and then you enter your search string. And when you do so, you get the results, but you also get a preview window for each result, and you can click on the results and see a small code preview window. So I really like this feature. And I found one class which also contained this method, the method onServicesDiscovered. And in my opinion, this method is very interesting because it has the UIDs in here which are used by the characteristics and the services in the GUT layer. And I found them already with Wireshark. And you also have some strings in this method. For example, this one here. And these strings are very interesting because I think they come from some logging factory, and you can use these strings for deobfuscation. For example, you can get the class name and the method name out of these strings. Or sometimes you even can get the variable name out of these strings. So when you want to manually deobfuscate your source code you are analyzing, you can click on a class name or a method name or a variable name, and then you can open the refactor function or dialog. And when you enter the name, and afterwards you click refactor, Android Studio asks you about all the local variables if they should be refactored. And again, you have here this preview window, so it's very fast to do so. and you can select them and then select all. But if you refactor something, in my opinion, it's very important to make some comment where you say, okay, this was CTB before I refactored it, because sometimes Android Studio is not able to find all variables, and afterwards you're really happy when you know, okay, which was the old name of that. Another useful functionality is the find usage functionality. You can click on a class name or a variable or a method and then press the Alt, Shift, and 7 key, and Android Studio will tell you, okay, where is this function used, what is class used. And after quite some time reverse engineering, I found a method, and I was able with strings I found in this method to rename the method to the class name Bluetooth Handshake Manager and to the method name device link parameter. And on the beginning of my talk, I said, okay, this is the first write command sent from the smartphone to the watch. And here in the code, you have a byte array which has the same values as part of this command. So this looked very promising, and we already know the name of this method. So this command has something to do with the link parameter. So I already mentioned it, static code analysis requires some effort. And yes, effort is a lot of work. And I'm a lazy person, so I decided to try something else. And that's where dynamic program analysis gets into the game. And there's a great tool called Frida. And Frida is a dynamic instrumentation toolkit for developers, reverse engineers, and security researchers. It's scriptable, so you can inject your own scripts. You can do function hooking, and you can trace application code. It's portable, and different operating systems are supported. It requires a rooted device. In theory, you can also use a non-rooted device, but then you have to modify the application you want to analyze, and this is not an option for us because of the code signatures check. And it requires the installation and execution of the Frida server on your smartphone. So I used Frida a lot during my reverse engineering process, and I want to show you one use case. I told you that the personal data are stored in an encrypted database on the smartphone. And in the data of the app, there are different databases. And I had no idea in which databases the fitness data and the health data are stored. But I realized that there's one database which is much larger than the other databases. So I had the idea, maybe this is the interesting one. So the interesting one is the HI Health _ 003 database. And what you should also check is the Android application you want to test or you want to analyze only starting itself, or does it start other services? And the health app also starts two services, a daemon service and a phone service, and they run with a different process ID. You can see that here. And when you work with Frida, you have to specify to which process it should attach. So this is very important, because in the beginning, I started with the Huawei Health process and was wondering why this database never gets opened. But then I realized that the database is opened in the daemon service. So I think it took me 2 or 3 days searching for the problem, why it's not working. And the only problem was that I was tracing the wrong process ID. Okay, so how does Frida works? In general, Frida is a command line tool. And when you use it as command line tool, you have to tip a lot, and when you tip a wrong character, everything is broken. But luckily, there's also a Python wrapper you can use, and you can see it here. I don't want to go into detail, but it's simply attaching to a process I can specify, and then it loads a script. You can see this here. It loads a JavaScript code where I script, or where you can script Frida. And here you can see the Frida script I used to get the data out of the database, so to decrypt it. And I think it's very interesting to see the capabilities of Frida, so I want to explain the code to you in a nutshell. There's the Java choose function, which you can use to say, okay, for this class, for the SQLite database, please search for all objects of this class on the heap. Find me all instances. And call this callback if you find one. And if you're finished, call the onComplete function. So each time a database was founded on a heap, I checked if it's the HI health database. And if it was, I created a non-encrypted copy of the HI health database. And this is really simple. You only have to check the documentation how you can do that. And since we got the instance of the database, we got an open database object, so we can call for the instance the methods which are available in your Android application. So you see, it's very easy to do so. It's not much work, but I was able to receive the whole database unencrypted with all my personal fitness data. Hell yeah. So, and now in the last couple of minutes, I want to talk about the Huawei link protocol. Parts of my research are already published in an issue on GitHub, and you can find it in the Gadget Bridge project. The Gadget Bridge project is a project where researchers try to leave the ecosystem for their fitness wearable. And I'm not the only one who is doing research on the Huawei link protocol, but perhaps the only one who is doing it for the Huawei Watch GT. So the other ones are doing it for the Huawei Band 3 Pro and for the Honor Band 4, and Honor is a sub-brand of Huawei. And we compared our results, and it seems that all the different Huawei wearables use the same protocol. So, what is the message structure of the Huawei link protocol? You remember our questions, what is this write command doing? Well, a message can be transferred in a single package or in a multi-package. A single package can be sliced or not sliced, and a multi-package, well, I found that multi-packages exist. I found it during the static code analysis, but I never saw it in action, so I have not further investigated it. So let's look into the single package not sliced. You have a constant here. Sorry. You have a constant here, and each message has this constant. Then you have 2 bytes of the length field. You have another constant. You have the content. We will come to this in a minute. And we have a CSC value, 2 bytes of CSC value over the complete message. So the structure of the content, we have a 1 byte service ID, we have a 1 byte command ID, and we have TLFs. So please don't ask me why it's called TLF. We found it in the strings of the Android Health app that the Huawei health developers called it like that, but I have no idea why it's called like that. If you know, so please tell me after this talk. And you can see that the protocol uses services and commands to address the commands. So here you can see the structure of the TLFs. So as I said, a command can have one or multiple TLFs, and each TLF has a tag, a length, and a data. And the length specifies how long the data is, and the length is a variable integer. So if the most significant bit is set, it uses 1 byte more for the length. Otherwise, it's using 1 byte. So I want to show you how the request link parameter or the request link command works. We already saw that during the static code analysis that it has to do something with the requesting the link parameters. And I already showed you the beginning of a message. So in orange we have constants, in blue we have the message length, in green we have the service ID, in brown we have the command ID, and then we have the data here, or the TLFs. And afterwards we have the CSE over the complete message. And here you can see the tags. It's quite simple. It says the first one here with a length of null, the second tag with a length of null, and so on. And to find out what exactly these tags are about, you have to analyze the source code. And here you can see the response from the fitness variable. So the beginning is the same, and then it says for tag 1, it has a length of 1, and the data is 2. So the protocol version is 2. For 2, we have a length of 2, so the max frame size is this value. And so on, and so on, and so on. And it sends you an authentication version, and it sends you some random. And the next step would be that the watch uses this link parameter to create some authentication between the smartphone and the watch, but that's a topic for another talk. So let's come to a conclusion. In my opinion, reverse engineering Android application isn't that hard, but it requires some effort. And if you're interested in a communication protocol, normally it's easier to reverse engineer the corresponding app instead of the embedded device. If you want to protect your Android application, you should remove logging strings in your release version, because that makes reverse engineering much harder. And yeah, it's possible to use the Huawei versions without the related Huawei ecosystem. And a side note, this is not possible for Fitbit, at least without a firmware modification. There was a very interesting talk last year at Easterhegg. If you're interested, I wrote you down the link to that. So in the end of my talk, I want to thank my employer and also my colleagues who are sitting here somewhere, because they helped me a lot in preparing the talk, and my employer allowed me to do some reversing during my work time. And since my colleagues helped me a lot, I want to help them. And 2 of my colleagues at the moment doing some research about the question, why do people think that their hardware devices are genuine and trustworthy. And they have some online survey, and if you complete this online survey, you can take part in a raffle, and you can win some Amazon vouchers, the value of 50 euros, or you can win some Austrian chocolate. The survey only takes 15 to 20 minutes, and if you take the survey, please enter my email address so I might also get some chocolate. Yeah. So I saw one person scanned this, the QR code. Thank you. Yeah, and at SBA Research, we are always looking for bachelor and master students who want to do their thesis with us. We also teaching some lectures at TOV, so it's not a big deal to do this at SBA. And we also offer some professional services to customers. So we are also always looking for motivated people who want to work as security consultants at our office. If you are interested in doing your thesis, or if you are interested in a job offer, please write me an email. Yeah, that's all. Thank you, and I would be happy to answer your questions.
Hi, one question and one answer. The question would be, how long did the whole process you showed here take you in real time?
I can't tell you really, but I think 300, 400, 500 hours. So I received the watch short before Christmas, and I used the complete Christmas holidays, but I worked 16, 17 hours each day on it. So it was really nerdy time. And I used some time during work. So yeah, let's say 300, 400 hours.
And the TLV, which you asked for, that just stands for tag length value. That's the standard way data is encoded in ASN1 according to the distinguished encoding rules.
Okay.
So it's just value and not data as you had it on the
Okay,
on the
great to know. Thank you for the info.
I hope my question is not off topic, but I mean, you showed in the end that you didn't interact with the protocol of the interaction, but that you hacked kind of the database. And my question is therefore, what is the raw data of the measurement device, in your case, the watch? Is it an ECG signal? Is it an infrared signal? Because the pulse is always an interpretation of like different spikes in those signals. And the other question is, what was then the data that you obtained from the database, which is already an interpretation? And that's why the data that you showed in the beginning in the matplotlib plot looked different from the data that the app had showed in terms of little spikes, where I wasn't sure, like, could you also get the raw data from the device? Question, please?
So I'm not sure that I got the first question, but the second question, in the database, you have pulse values, so 80, 90, something like this, and you have a timestamp when it was recorded. So that's the data for the heart rate in the database.
Which raw data is recorded?
You get the same values when you extract it over Bluetooth. So I got the same values over Bluetooth, if this is the question. You can also ask it in German, maybe this is easier.
Wenn das übertragen wird, dann kann ja schon in der Übertragung, also kann ja auf der Ebene der Uhr schon eine Interpretation stattfinden dieser Daten.
Ja, absolut. Aber die Daten waren sowohl in der Datenbank als auch während der Übertragung dieselben Daten. Also das waren schon die Pulsdaten mit einem Timestamp. Also wenn es eine Interpretierung gibt, dann passieren die schon auf der Uhr. In dem Mikrocontroller auf der Uhr. Das war die Frage, oder? Okay.
So you mentioned that Android apps forbid to be backupped and to be debugged, I think.
Yes.
on rooted devices, does it still apply? And if so, is there some way around that?
Now, the problem is, normally on a rooted device, it's not a problem to change the debuggable flag and to install it back. But I was not able to do so because of this obfuscation tool, which where bug is in APK tool, that you bring it back. Because you can only debug an application if this debugable flag is set to true.
But it's something that the app's manifest asks the runtime, the Android runtime, to please not to, right? The Android runtime could, in principle, just not care about that flag, right?
Of course, if you overwrite it with reader or something like this, you can do it with a rooted device, then it's not a big deal. But in the simply Android workflow, as far as I know, but I'm not an Android expert, it's not that easy. So you have to override it with reader or some other instrumentation tool. I think so.
All right, thanks.
Okay, I think. Then thank you very much for coming.